prepared PPTs, and I will show you PPTs where you can understand the concept of non-destructive testing. So let me present the screen now. Whether it is visible to you, please reply in the chat box whether the NDT PPT is visible to you. Dhanashri. Okay, it is visible. So non-destructive testing is the testing method in which the cracks, blowholes, pinholes, and any surface irregularity is detected. There are two types of tests already we have studied. One is destructive test and another is non-destructive test. Destructive testing was used for measuring the mechanical properties. Which mechanical properties? Hardness testing, tensile testing, creep testing, fatigue testing, then various properties such as elongation, yield stress, ultimate tensile stress. Okay. Now, aim of non-destructive testing is different. Aim of non-destructive testing is totally different than destructive testing, which was explained by me in the last class. So, in today's class, let us see one by one all the techniques of non-destructive testing. I repeat once again, in my previous class, I have told you this non-destructive testing, there are different examinations, level 1, level 2, level 3 examination. And if you will pass this level 3 examination, you will be international recognized person. So you can have your bright career in that field. So let us see, this is as far as part of curriculum is concerned. We are going to study it, and the questions probably asked on this topic covers in MCQs, it covers in subjective, as well as it will be the part of your external oral, and definitely if you are going to appear for the interview in any core company, these questions may be based on non-destructive testing because it is used for inspection of the casting, rolling, forging, and any of the manufactured product. So this is the classification of NDT, short form of non-destructive testing is NDT. So I request friends, if I will not be audible, please drop the message in the chat box, or at least you unmute yourself and please convey me, because I didn't put headphone in my ears. So if you will say ki you are not audible, then I can manage from here by rejoining once again. Okay, we'll continue. Non-destructive testing is classified into following types. You can take screenshots of this PPT. Then sound test, then magnetic particle test, then dye penetrant test, then ultrasonic test, radiography test, ED current test. So visual inspection, sound test. These two tests are non-standard tests. I think I have explained you about visual inspection and sound test. So if sample or the specimen is small, you are supposed to take that specimen in hand and you are going to see it. But if the specimen is of larger size, you are going to move around the specimen and you can check the presence of cracks, blowholes, pinholes in the casting. So this visual inspection only gives location of the crack on the surface. Subsurface crack means below surface level, it is not visible to you by your naked eyes. So that's why this test is non-standard test. Now, second is sound test. Sound test I have explained you. I have given the example of adhan pot. Adhan pots are knocked with the help of fingers or by a piece of coin or maybe metallic piece, so that the ringing sound of the adhan pot reflects that there is no presence of any crack. Metallic parts you can't do by hand or manually. You are going to use some metallic rod, and that metallic rod you can use for making the impact on the component, and that impact, it will give some sound, and based on that sound you can judge whether the casting or forging or any of the manufactured component is okay or not. If there is no presence of any crack, it will give good ringing sound. But if there is any crack, not only at the surface but also inside the surface, which may not be visible to you, then it will give dull sound. That's why skilled operators are required here to judge the sound quality. That's why this test is also non-standard test, because one person can hear the good sound, another may not. You can't judge whether it is accepted or rejected. Let us go to the next test, that is magnetic particle test. One minute. I just select the pen. Magnetic particle test. What is meaning of magnetic particle test? Try to understand the importance. The parts which can be magnetized means usually ferrous alloys. If this part you will be able to magnetize, then with the help of iron powder, you can find out the presence of surface cracks. Now, what exactly is covered under the magnetic particle is explained in the next slides. Before that, let us just see the names of the test. Dye penetrant. See, the spelling of dye is D-Y-E, not D-I-E. D-Y-E, dye means color, and D-I-E, dye means mold. That dye and this dye you don't mix. So, D-Y-E, dye penetrant means color test. Next is ultrasonic test, radiography test, eddy current test. Magnetic particle test. You can take screenshot. Now, this is simple right hand thumb rule. Right hand thumb rule explains that if current is flowing in the direction of thumb, then direction of fingers will show the magnetic field, and vice versa. Vice versa means if fingers will show the direction of current, direction of thumb shows the magnetic field. So based on this principle, the magnetic particle test is working. You can just see this. You can take screenshot also, because this is just principle. Now I'll explain you how exactly this test works. You can take screenshot of this for 1 minute. I will wait. Recording link will be available, no problem, but even good quality of figures are there. That's why I'm asking. See here, this is left hand side figure where the current is in the coil, which coil means showing fingers. Then magnetic field will be in the direction of thumb. If you see, two cracks are shown here. I will use this pen for identifying. See, this is one crack present on the rod, and here is another crack present on the rod. Here is one more crack. Red color indicates that crack is detected, transverse indication. And longitudinal field means magnetic field is in this direction. The cracks which are perpendicular to magnetic field are only detected. Write down this statement. In case of magnetic particle test, cracks which are perpendicular to magnetic field are only detected. The crack which is parallel to magnetic field is not detected. That's why it shows faint here. This is faint, left hand side, see here. Whereas this side, right side, if you see, transverse indication by dark color. Same figure, if you see here, here is a crack. Magnetizing current is in the direction of coil, and magnetic field is perpendicular to the current direction. And crack which is perpendicular only detected. It doesn't mean, sir, here there may be crack in this way. Here there may be crack in this way. But it is not detected. Why? Because field is parallel to that crack. When field is perpendicular to the crack, only that crack is detected. Remember. We'll go to next slide. Now see, all types of cracks are shown here. You can take screenshot. Magnetic particle test, left hand, see all the arrow marks. Earlier coil winding was different. This coil winding is different. This is a black is a color of coil through which current is passed. And then there are various cracks present on the bar. Three colors are used. This color is a dark color. This color is faint color. And this is again very faint color. These are three cracks. See here, circumferential will show. Means what? If crack is perpendicular to the field, it will show clear indication. If crack is inclined, it will show faint indication. And if it is parallel, it will not show indication. Now friends, indication means what? See here now, I am telling the logic behind it. Now you understood, when crack is perpendicular to magnetic field, it will be detected by magnetic particle test. Means what? How to carry out this test? So on this rod, where you want to find out the cracks, iron powder is sprinkled. Iron powder is sprinkled. It may be dry method or wet method. Iron powder is sprinkled. Then immediately if you make current on, the powder which is spread throughout the surface is accumulated in the or at the position of crack. If crack is strong, means perpendicular, magnetic field is strong at the position of crack, more powder will be accumulated. If crack is not perpendicular exactly, less powder will be accumulated. And if crack is along the magnetic field, no powder will be accumulated. Logic behind it. See, this is magnet. I am drawing here. This is N and this is S. If this is the magnet, and if you will break this magnet from here, if you break this magnet from here, you will find this S as it is, and once again N and S and N. In this way, once again there will be pole formation. So this pole formation Not necessary to break into pieces. Even if there is a small crack in this way, N, S, and here also N and S. In this way, when there is presence of any crack, there will be formation of poles, NS poles. And always remember, the magnetic field is maximum at poles. You can do the experiment. Take one magnet and just put the iron powder. And if you put the magnet there in the powder, you will find, or even take the nails, hundreds of nails, and you put one magnet there. This lab type magnet, which is a square cross section, available in physics lab, etc. You have seen. You will see that majority of the nails will be attracted towards the poles. So at pole side, maximum attraction is there. Hence, when there is presence of any crack, there is a pole formation. Due to this pole formation, the attraction is more. And hence, earlier if you sprinkle the powder and current is off, the powder remains sprinkled for as it is, like a layer. But as soon as you make current on, that sprinkled powder will accumulate at the position of crack. And then you have to take some clean cloth, remove that accumulated powder and make marking with the help of marker. And you can decide whether this crack is acceptable. Okay, you can send it as a okay product. If you find this crack is not acceptable, it is rejected. But before rejection, it was checked, can it be repaired, and then again it will be accepted. This is the principle of magnetic particle test, which is covered. Now, always there is no component, no component is always round in shape like this. Suppose there is a big table, assume that my staff table or any of the laboratory table, such shape of the component is there, and you want to find out the presence of crack at the surface. Then what kind of mechanism is used in magnetic particle test? This is explained in the next slide. Before that, this principle once again: field direction, perpendicular, strong indication, inclined indication possible, little more inclined still possible, but when it is parallel, in this case, no indication possible. So it is shown here, no indication possible, means this crack is present, but iron powder will not accumulate there. At this position, strong indication, more powder will be accumulated. This indication possible, less powder will be accumulated. So depends upon accumulation of the powder, you can judge what is severity of crack. See how at actual photograph, it is clean, and then magnetic field is applied for checking the presence of crack. So I was telling this. This is called as magnetic yoke. So this is magnetic yoke, this is one end, this is another end. So from here to here, directly magnetic field is there. I will draw the lines. These are the lines of magnetic field. These are the lines of magnetic field. So if there is any presence of crack, in between, then that crack should be, I will take some different color. So if crack is present in this way, which is perpendicular to magnetic field, that can only be detected. I repeat once again, in this case of magnetic yoke, directly magnetic field is passed from here to here. So this crack is detected. If the crack is in this position, it will not be detected. Okay, so only perpendicular cracks. So this is the procedure. Pre-clean the test surface, magnetize it, So what is written? Field forms instantly. Field means magnetic field is formed instantly. Apply the ion particles or powder an indication in this way. So this is direction of field. This is direction of field, and that's why crack is detected. So you have to remember these steps. First cleaning, second magnetizing, applying or field generation, powder application, and indication. See, here I was explaining this to you. This is N. I will take some different color. See, this is N pole, this is the S pole, and if there is any flux leakage, means if there is any crack, you will find here will be accumulation of powder. Now here two different aspects are there. I will divide this into two parts. Right hand side, directly magnetic field is applied, and left hand side, current and field is there. It is as like previous case. So here this one and this one, these are the two probes. They are passing the current in this way. This is a welding. So current direction is here, then magnetic field is perpendicular, then this crack will be detected. But if crack is present in this way, this crack will not be detected by this position. For that purpose, see second figure. The location of probe is now kept on the weld. That will be direction of current. And then this will be direction of field. And that's why this crack is detected. In right hand side, these are the magnetic yokes. These are directly passing the magnetic field from here to here. And then this crack is detected. But if it is cracked along the weld, you require to keep yoke in this way. And if it is perpendicular to weld, means in this side, you have to put the yoke in this way. So I hope you have taken the screenshots. Now dye penetrant test. Dye means color. Now the parts which you can't magnetize, for example aluminium or any other metal, copper, its alloys, if it is not able to magnetize, how can carry out magnetic particle test? So for that purpose, this dye penetrant test is used. Now what is the limitation of magnetic particle test? You can write down it. Limitation of magnetic particle test is it is suitable for surface cracks present on the part which can be magnetized, and subsurface cracks up to 6 mm depth. So from surface that crack is not visible, but if it is below 6 mm, so this I will show you here. See, such faint locations are observed, or here such faint locations. If even it is below surface level, some powder will be accumulated. Even you take the lens below that powder accumulated area, you will not find the crack. It means that crack is below that surface, but limitation of magnetic field penetrating in the part is only up to 6 mm. Below 6 mm you can't check the parts. The parts which you can't magnetize or can't check with the help of magnetic particle test. And the parts which can't be magnetized are then tested with the help of dye penetrant test. Same steps are there. This is your part. Step number 1, clean the part. Step number 1 is cleaning. Now cleaning is carried out with the help of cloth, but many times there are oil particles, dust. So some chemical cleaner is required, and then that chemical cleaner is applied and part is made clean. Then apply the color. In this way, color is applied. If there is any crack, this red color will go inside the crack. And then you have to remove the excess color from the surface. Take the cloth and wash the excess color from the surface. But if crack is present, that color goes inside that crack. And then apply the developer. It is sodium carbonate powder. So it is white in color. And you can do the experiment. If there is a leakage in your pen, you are putting the chalk near to it. So that chalk is absorbing the ink. Same way, this developer absorbs the ink from the crack. And the picture will be like this: white blanket and red spots. White blanket and red spot means that is a crack. You have to immediately take the pen and make the marking with the help of marker. Otherwise, that crack, ink will be sprayed, dye will be sprayed, and you can't judge the severity of crack. See this now. Component should not be dirty. So before cleaning, this is before cleaning, and this is after cleaning. So after cleaning, component will be this much clean. So this quality of cleaning is required for carrying out the test. Then clean the surface. Then apply the penetrant. It is red in color. Clean the penetrant means you have to wait for 5 minutes. Penetrant will go inside the crack if any. Extra color is removed with the help of cloth. Then apply the developer and then examine. What is function of developer? Developer is white in color. It will absorb the dye present in the crack. So on the white blanket, you will get the red spots. Okay? See here, actual photograph. This is weld. You are observing the red spot, means some blowholes, pinholes are present. Then here is again crack. Here at the corner there is presence of crack. Now what is this shining color? Remember, you are observing some green light. That is presence of crack at the head of or at the neck of bolt. In dye penetrant test as well as in magnetic particle test, there is one concept: fluorescent color. What is the concept of fluorescent color? Fluorescent color is the color which shines in the presence of ultraviolet light. So that fluorescent particles are added with ion particle in magnetic particle test and in dye penetrant test. So that if you check the measurement in dark in presence of ultraviolet light, so in upper cases you are observing red spots, there you will observe greenish color. So because that fluorescent particle will come out along with color, and ultraviolet light will detect them. So remember, the importance of fluorescent color is it shines in the presence of ultraviolet light for easy detection. This is all about dye penetrant. So the most important limitation you can write down. The most important limitation of dye penetrant test is it is used only for surface cracks. Any type of material, magnetic as well as non-magnetic, can be checked, but only surface. Because dye will not go in the surface until and unless there is a crack. This test is not suitable for porous material. This test is not suitable for porous material. Why? Because you will not able to judge where are the pores and where are the blowholes. 1 minute. Now, let us go to the next slide. Next test is ultrasonic test. Now, I want one answer from your side. Please answer my question because it is based on the principle of this. Tell me, what is the velocity of sound in air, liquid, and solid? Where it is more? Air, liquid, and solid. I repeat my question. Velocity of sound is more in air, liquid, or air, water, and metal. This is interview question. Reply somebody. Solid. Any other opinion? Velocity of sound. I repeat once again. Please answer. I want answers from maximum students. Velocity of sound is more in air, water, and metal or solid. What is the answer? Any other student than Dhanashree? You don't know? So always remember, friends, velocity of sound in air, it is 346 meter per second, you know that. But velocity of sound in liquid is more than air. And velocity of sound is more in metal or solid than water. So is it contradictory? You may feel, you might be knowing this, you might be, or you may not be knowing this. But remember, velocity of sound in solid is highest than liquid and it is highest than solid air. Now, we people are talking, these are just simple sounds, but I am talking about ultrasounds. So ultrasonic wavelength and other frequencies are different. So if you talk, you can hear the person who is staying there. Suppose your one of the friend is below water level, he is swimming, and if you are talking from the top, he will not able to listen you. Why? Because your sound waves are not ultrasonic. And one of the most important principle of sound is sound waves reflect as soon as medium changes. So when you are talking with the friend who is below water level, medium changes. That's why your sound waves will not go inside the water and he or she can't listen you. No doubt of talking from his side because he can't talk as he is below water level. Now, this principle is used for checking the presence of cracks, blowholes in the metallic or metals or alloys. If you consider one component, suppose this is the component I am drawing. And this is a probe. I will send a sound wave from here and suppose this distance is 1 meter. Then some recording is there with the help of this wire. sound waves are going from here and they are coming here and again they are going back. Why? Because you have kept it on ground and there is a small gap, and then medium changes, sound wave reflects. So suppose this specimen is a standard one, which is not having any crack or any irregularity, any shrinkage hole. Suppose it takes 5 seconds to reach here, so it will come here 5 seconds, it will go back 5 seconds. If you hear the signal after 10 seconds, it means that there is no crack, because already we know that this part is without any crack. So in this way you go on moving this. Suppose this is first signal, this is last signal. This is first signal, this is last signal. So if you will get these signals every time for 1 meter component, which is a standard one, then every time you will get peak, or you can say every time you will get the beep, awaz. Peak is the value here which is shown, and if you are getting it after every particular time, suppose 10 seconds, means part is standard, it is not having any crack. But if here is any crack, your sound will come here. Crack means change in medium. It will not come down. Immediately it will reflect back. So earlier beep was heard by you after 10 seconds. But if you hear the beep after 6 seconds, it means that sound wave have not reached up to the end and it turned back within 6 seconds from the distance in between. So in this way, on the indirect basis, you can judge that even it is not visible to you, you can judge that there is a crack below surface level at so and so distance, which is shown here. Initial echo, back wall echo at this distance. Okay, but if you will get reflected one more beep in between, it means there is a flaw. Flaw means crack. Directly on the CRO tube, cathode ray oscilloscope, you are going to get the presence of crack. This crack is not visible to you. You are getting the signal for presence of crack. And logic I told, sound wave reflects as medium changes. If you take the standard component and another jobs of the same length, and if you check this for passing the sound waves, you will get that if sound wave will not come back in the standard time and it will come back in less than standard time, there is a presence of crack. Now one more crack may be present here. How can you check it? Can anybody give answer? I have drawn one more crack here. First crack is here, sound wave reflect and go back. Now there is one more crack. Can anybody tell how this crack? You may say that yes, there is one crack. But what about this crack, which is exactly below the previous crack? How sound wave will reach here? Tell. Answer it. Please answer it. Nobody is having answer? Dhanashree.
Yes, sir.
Please answer. My question is, if crack is present below the first crack, sound wave will not reach there. How can you judge? How can you check this crack?
No idea, sir. I think some amount of sound is also going.
No sound is going, because it will be reflected from the first crack itself.
Then we are uh,
Answer.
yes, sir. We are sending sound from another side.
Very
That's why.
good. Correct answer. Same thing is done here. You have to rotate your component upside down, and from all the sides you have to send the sound. Then only you can check the presence of crack. It is like we are doing sonographies. So appendix operation here, if there is any presence of irregularity in our body, the sound waves will be reflecting, and the sonography specialist, they are working on it. They can judge it. Even in case of pregnancy, the sonography tests are carried out based on same principle. So it is shown here. This figure also you check presence of crack, sound wave reflect back. Now, if this crack is to be tested, sound waves are sent from this side. And then you can check from how much distance. So the advantage of ultrasonic test is it will be used for checking the subsurface cracks. Subsurface crack means below surface level. But what is disadvantage? Disadvantage is you can't see the crack. म्हणजे क्रॅक आहे जे त्या सरफेसच्या आत एवढंच माहिती आहे, पण तो कसा दिसतोय हे माहित नाही. कुठे आहे हे माहिती आहे, पण कसा दिसतोय हे माहित नाही. And for that purpose, some another test is used that I will show you in the next slide. So next slide also shows the position of the probe. See here, 1, 2, 3, 4, 5, 6. Every time the location of this probe, angle of sound is changed, and then you can check the presence of crack. This is sender, this side is sender, and this side is receiver. Okay. So I am talking about this test now. This is the standard test, which is not only giving presence of crack, but also it gives location and picture of the crack. Very simple. When there is a crack in our bone, doctors are taking the x-rays, and same thing here also we are going to take x-ray of machine. So if any crack is present in our body, in any of the bone, you can see the picture film. Doctors are showing you the film. Even your complete skull, maybe hand, maybe thigh, maybe knee. Doctors are showing actual figures and their presence of crack. Same concept is applied. If you have the unit of X-ray and gamma ray radiography, you can check presence of crack in the machines also. See here, there is one more concept of, not concept, there is one more curriculum. One course is there called as piping engineering. It is available in some of the college in Pune. So if you go through that course for 1 year, maybe it's like a diploma of 1 year or maybe 2 years, then it will be additional certificate for you as a mechanical engineer, and you will get great opportunities in the Gulf countries, petroleum and other factories, because these pipes are running kilometers and kilometers from one country to another country, and if there is any crack present, it will cause the explosion. That's why online detection of presence of crack is carried out with the help of X-ray unit. Now you have seen different X-ray unit in hospitals. Here there are portable units. See here in the one person is developing the film. So here one person film is shown, but where is X-ray unit? It is inside. Check this figure. This is X-ray unit, and then the films are first exposed and then they are developed, and you can see actual presence of crack inside the body part. So thickness is very small. Thickness of the pipe may be 5 centimeter, but inside that pipe, if there is any crack, it may cause a leakage of the oil, it may cause a leakage of the hot gas, explosive gases or petroleum products. Hence, if you find there is any leakage, that pipe is repaired. So piping engineering is one of the course. Remember it. You can Google it. And if anybody interested after B, you can join that course. So I hope you understand the radiography test. It is like taking X-ray of the machine. One more additional information I will give. There are two types of radiography. One is X-ray radiography and another is gamma ray radiography. X-ray. And another is gamma ray. Gamma ray radiography is radioactive element is used for producing gamma rays, and X-ray tubes are used for creating the X-rays. So there is a difference between X-ray and gamma ray. Gamma rays are produced by radioactive element. That's why they are spreading all over the area. That's why if you keep the component at the center in this way, gamma ray unit, and if you arrange your product surrounding to it, at a time it will expose all. But it is not like in case of X-ray. In case of X-ray, it will be directed only in one direction. The penetration power of gamma rays is more, wavelength is less. So in this way, you can create the difference between X-ray and gamma ray. The main advantage of X-ray test is it is not only used for subsurface cracks, not only severity, but also it will show actual location and actual figure, actual photograph of the crack. This is last one, ED current test. See the figures carefully. Now the principle of ED current is little different than this other. ED current is secondary current, which is generated in the product. Primary current is passed through the coil. Now what is the outcome of ED current test, or what we are exactly doing with ED current test? ED current test is not only used for checking the cracks, but also it is used for sorting of the components. Because ED current means what? ED current is the secondary current generated when primary is kept or winded on the specimen. The specialty of ED current is ED current based on shape of the component, type of the material. Listen me carefully. Shape of the component, type of the material, then presence of any surface irregularity in the component. If it will change, ED current will change. Now I have manufactured 1,000 components, and in that 1,000 components, some parts are having crack. Suppose there is no crack. I have intentionally created one oil hole in 15 parts. आणि हे 15 कंपोनंट त्या 1000 कंपोनंट मध्ये मिक्स झालेत आणि होल एकदम छोट आहे. तर काय करायचं, सगळे कंपोनंट ED करंटच्या मशीनवर ठेवायचे पटापटा पटापटा. होल असणे म्हणजे सरफेस इरेग्युलरिटी, ग्रूव असणे म्हणजेच पण सरफेस इरेग्युलरिटी. प्रत्येक वेळी क्रॅकच पाहिजे असं नाही. सो इफ देर इज एनी प्रेझेन्स ऑफ सरफेस इरेग्युलरिटी, you will get different frequency of ED current. So standard part will give different frequency of ED current, and defective part or surface irregularity part will give different frequency of ED current. And hence you can easily sort out the components which you need. So this is all about ED current test. Okay. So non-destructive tests are magnetic particle test, only surface crack and subsurface crack up to 6 mm. Used only for parts which can be magnetized. Dye penetrant test is used for the parts which can't be magnetized, but limitation is only surface parts, cracks. Ultrasonic test is used for subsurface cracks, but only it can show the location, but not the shape. And last one is radiography, which is not only showing the position of the crack below surface level, but also shows the actual photograph of the crack. So this is all about ED current test. So these are various figures. You can take screenshot of it. Standard component left hand side, right hand side. If there is a defect, you'll find how ED current is varying. Okay. This is all about non-destructive testing. Just wait. I will take your attendance. So I will upload these notes of this chapter. I think I have uploaded. I will confirm once again. If not, I will upload once again. Thank you. We will stop here.